Hey guys, welcome back to my channel. In today's video, we are going to discuss how to print all the factors of a number or how to print all the divisors of a number. So what is a factor? What is a factor? A factor is a number that divides a number completely. Let's say n is given to you. A factor of n will be, let's say, x. So n modulo x will be always 0. That means x is dividing n completely without any remainder. So that's what factor is. So let's say a number is given to you. So okay, so let's say a number is given to you, maybe 16. What are the factors of this number? 1 can divide 16. Yes, 1 can divide. 2 can divide 16. Yes, 2 can divide 16. 3 can divide 16. No, 3 cannot divide 16 completely. There will be some remainder. Okay, 4 can divide 16. Yes, 4 can completely divide 16. 8 can divide 16. Yes, 8 into 2 will give 16. Okay, 8 is dividing 16 completely. And then 9 cannot, 10 cannot, 11 cannot, 12 cannot, then 16 can divide 16. So these all are the factors of 16. So you basically have to print this. So the brute force way is to basically check all the numbers between 1 to 16, and for each number, let's say you are running a loop from I equals to 1 till I is lesser than or equals to 16, and you are checking whether the 16 is divisible by I or not completely. So this is how you check. If it is, then you will store the answer or you will print the answer. Otherwise, you won't do anything. You will go to the next index, right? So this is the brute force way. So let's write it clearly. So you'll be like, n is given for int I is equal to 1, I is lesser than or equals to n, I plus plus. Here what you are going to do, you will be checking whether n is completely divisible by I or not. If it is, you will be like printing what? Printing I. If it is not, you won't take this or you won't get into this condition, you will go for the next index. So whichever I satisfies this condition, that means whichever I divides n completely, you will be printing that. For the rest, you won't be printing it. So this is the most brute force approach. So the time complexity will be of n. Why? Because if n is given to you, let's say here n was 16, you will iterate from 1 till n, right? So that's how the time complexity is of n, and space complexity will be of 1 because we are not using any extra space. What if I say you can still optimize this? You can still optimize this. So how to optimize? Let's see. Let's look into some patterns, or let's look into something. Let's say 16 is the number. Can I say like first, let me just write down the factors 1, 2, 4, 8, 16, right? So these all are the factors. See, if 1 is dividing 16, that means 1 into something is equals to 16. That means 1 is of course dividing 16. But this number, let's say x is also dividing 16. So in this case, 1 into 16 will be 16. So 1 is dividing 16, 16 is also dividing 16. So we got two numbers. Similarly, if 2 is dividing 16, so let's say 2 into something is equals to 16. So what is this something? Let's say it is x. So what is x? X will be 16 by 2, right? So it will be 8. So 2 into 8 equals to 16. That means here 2 is dividing 16 completely, and 8 also divides 16 completely. So let's write down something for each of these factors. Let me just write down the table. So 1 into something is equals to 16, 2 into something equals to 16, 4 into something equals to 16, 8 into something equals to 16, and 16 into something equals to 16, right? So these all are the factors. So basically we iterated from 1 till 16 to get these values, right? So let's find out like what this other number is. So 1 into 16 is 16, right? 2 into 8 is 16, 4 into 4 is 16, 8 into 2 is 16, and here it's 16. Okay, 16 into 1 is 16. So basically, can I say that do you really have to iterate till n or till 16? Do you really have to iterate till 16? Observe the pattern. 1, 2, 4, 8, 6. But this 8, 6 is here itself. Sorry, this 8, 16 is here itself. So can I say that, while finding 1 and 2, I can find 16 and 8 also. So we don't have to iterate till n. We just have to iterate till root of n. Actually square root of n, right? Square root of n. If we iterate till square root of n, if I is completely dividing n, then n by I also completely divides n. So what I mean to say is, if this is I and this is n, what is this? This should be n by I, right? This should be n by I. Let's say this is 2, this is 16. So 2 into what is 16? 2 into 8 is 16. How you got to know? Because 16 divided by 2 is actually 8, right? That's how you got to know. So if I is dividing 16 completely, then n by I also divides 16 completely. So that's how you will find the answer. But see here, when I is equals to 4, 4 into 4 gives 16. So in this particular case, you don't have to take I and n by I. You just have to take any one because both are same. So take it only once, right? So that's how you will be writing the code. So the code is very simple. So first of all, I'll be coding for the brute force approach. So int n, I'm getting the inputs. So I'm just running a loop from I equals to 1, I less than or equals to n, I plus plus. Then for each I will be checking whether I can divide n completely or not. So n modulo I, if it's equals to 0, then print the I. That's it. That's it, and you will get the answer. So let's say I'm giving 16, 2, 4, 8, 6. Perfect. Now this runs from 1 till n, but what I am saying is I can run from 1 till square root of n, right? So I will be lesser than or equal to square root of n. And what I am going to do, if I is dividing n completely, I will of course print I, but I will check whether n by I is equals to I or not. If it is equal, I don't have to print it, but if it is not equal, that means n by I is also a number that will divide n completely, right? So I will just print n by I. And why I am writing this condition? Because see, if you remember last time, 4 into 4 gives 16. 4 into 4 gives 16. That means when I is 4, n by I, that means 16 by 4 gives 4. So I don't have to print 4 twice, right? So if I is equals to n by I, then print any one, right? Anyway, I am printing I here. So I don't have to print n by I again. So that's the reason I am checking it, right? Whether n by I is equals to I or not. If it is equal, don't go inside this. If it is not, that means there is some other number that is n by I that divides n completely. So let's run this code. Let's run this code. Yeah, 1, 16, 2, 8, 4. I think there is some enter mistakes, so let's give space only. Oh yeah, 1, 16, 2, 8, 4. So now it's not in a sorted order, right? So if you want to sort it, just put them in a vector. I'm just putting them like push back I and n by I also. I'm giving it into a vector, and at the end I'm just sorting it. And then using for each loop, I'm just printing the I. If you don't understand this, don't worry, it's a for each loop. So let's just run this. Okay, there is a mistake. Okay, see, now 1, 2, 4, 8, 16. So that's how you will be solving this problem. So that's it for today. If you like the video, hit the like button, subscribe to our channel. Until next time, see ya.